Hi students, this is Vodcast 1 for your atomic structure unit, part 2 of your atomic structure unit. Today we're going to be describing the arrangement of electrons using the Bohr model and the quantum mechanical model of the atom. So on your checklist we're right here, Vodcast 1, electrons in atoms. Alright, so we have to compare and contrast that Bohr's atomic model with the more current model, now known as the quantum mechanical model. What Niels Bohr suggested was that outside of the nucleus, electrons travel around the nucleus in specific energy levels. They orbit that nucleus kind of like planets orbit the sun. And that area outside of the nucleus we call the electron cloud. So a couple different pictures of Bohr's planetary model are right here. I'll kind of start with the easier one down here. Here's the nucleus of an atom. Around it are almost like hula hoop rings where electrons are found. So each one of these rings is called an energy level. This first energy level holds 2 electrons, 1, 2. The second energy level can hold up to 8 electrons. The third energy level out here, if this atom had it, would hold up to 18 electrons. So here's the nucleus, and these little rings represent energy levels where atoms orbit like planets orbit the sun. You might also have seen Bohr's model represented this way. Here's the nucleus. These rings right here represent those energy levels. And this was a good model, and it gives us a basic understanding of how electrons are arranged in atoms. And sometimes you'll still see this model used, even though we found out that it's now incomplete. So if I were going to draw a Bohr model or a planetary model for neon, here's neon on the periodic table. This 10 up here tells us it has 10 protons and also 10 electrons. So if I take a look at an atom of neon, here's the nucleus with 10 protons, and it also has some neutrons in there. Here's my first energy level with 1, 2 electrons in it. And then here's my second energy level with 8 electrons in it. And you'll see they're paired up. This is usually the way we draw these. That is what we would call the Bohr diagram, or the Bohr model of an atom. A little bit bigger atom is down here, chlorine. Here's the nucleus, 17 protons. There's that number 17. This one happens to have 18 neutrons in it. Remember, the number of neutrons in a nucleus can vary. Here's my first energy level with 2 electrons in it, second energy level with 8, third energy level out here. So there's a total of 17 electrons in a chlorine atom. This is a basic model of how electrons are arranged in atoms, and it's good, but it gets way more complicated. And the more complicated model is called the quantum mechanical model. This model states that electrons are likely to be found in energy levels, but within these levels are three-dimensional areas called orbitals that have very complex shapes. And not only do these have complex shapes, but we found out that electrons do not orbit the nucleus like little planets. They zip all over the place. Their behavior is called erratic. And really smart people can predict where these electrons are going to be using a lot of mathematics, but it is just a prediction. So here's the quantum mechanical model of the atom. It still has the nucleus in the middle. It still has the electron clouds out here. It still has this sphere right here represents one energy level. This gray sphere represents a second energy level. But as you can see that within these energy levels are funny shaped orbitals. This is called the 1s orbital. It's spherical. This is a 2s orbital, okay, and that holds 2 electrons. And then these funny red shapes in here, these are what we call 2p orbitals. And electrons are also existing within these three-dimensional spaces. So this provides a more accurate model of what we understand about the atom now. We know that electrons do not orbit the nucleus the way we thought they did. And it gets pretty complicated. But as you move throughout this unit, your next activity is this Annenberg interactive simulation. And I think after working through this, you'll have a better idea of exactly what that quantum mechanical model means. And then we'll take that information and we'll tie it into the periodic table. This is the end of Vodcast 1.